I'm gonna start recording. It's a little later than I thought. Oh well, okay. So hopefully everybody's getting through the homework's okay. It seems like for the most part everybody is.
Hey
Today,
Tom,
huh?
Tom, I just turned that analysis paper in. My dogs have been in and out of the hospital all weekend, so
Oh, okay. Your little summary paper. That's all right.
yeah.
Yeah, it'll let you submit them. It just tells me if they're late or not. But yeah, we can get that through for you.
Okay.
Like I said, I have a couple of writing ones for you guys. Just because it's like today's technician, you got to be able to write a couple of words and stuff for your daily reports and whatnot. That's just how our thing is now. Work reports and work reports.
I do more time sitting at a computer closing out work orders than I do actually doing the work.
That was always, and I hated having emergencies come up at the end of the day because I swear, like the last 45 minutes of my day was literally sitting at the stupid computer, yeah, writing out work orders, what I did and everything. I was like, oh my God. Yeah. Well, let's see here. So today we are going to talk about chapter 2 and hopefully take some of this mystery out for you guys. So hopefully by now everybody knows that an electrical outlet is a box where you have wires coming out, okay? And that's an outlet. So different things can go in that box. So if we have outlets that have receptacles in them, we have outlets that have switches in them. But basically, the rule is, yeah, if you have wires coming out to be utilized by something, that box is considered an outlet. And chapter 2 talked a little bit about the ways to mount things, like how you can mount the box inside of the wall, put a position and everything, what your heights would be. Um, Even to the point where we talked about, like, I think chapter 2 went through and talked a little bit about the maximum number of conductors. And we talked a little bit about that last time too, but you do have a limit, and you're limited. Basically, the NEC even has, based on box dimension sizes, how many conductors it can have in a box. And your rule of thumb is what they call 6 inches. So when you have 6 inches of wire inside of a box, that's considered one wire. And anything over 6 inches makes it count as two wires. So if you had like a wire that was in the box in an outlet that's 12 inches long, technically you're supposed to consider it as two wires because that's how much space it would take when it's pushed inside of the box. And so there's limits to how much wiring is allowed within an outlet, simply because of the heat involved for expansion and things like that. And again, it's all about fire prevention. But I'm rambling on here. We'll start looking. We look at so I know you should have seen like some of the electrical symbols that are used on plans. Chapter 2 basically goes in and starts talking about plans. And for every building, you always have a set of prints, the plans that are involved or what to build the building by. And pretty much those set of prints will stay with the building for the life of the building. And technically, any changes you make, you're supposed to update your plan so you have a current copy. A lot of homes don't typically do this, but for more official places like stores, even factories and warehouses and whatnot, keeping an updated set of prints is actually kind of important. But so a typical room style, as we've seen hopefully from doing the homework, and you've seen these curved lines that are drawn out there. And the reason they do the curved lines is to basically keep it from being confused with like the wall the wall drawings and such. If we started drawing rectangular lines out, you could confuse that as actually being part of the overall dimensions of the plans with the walls and things like that. So they typically, you'll notice they do use curved lines. And in this case, where we have this light is controlled by two separate switches that are to be mounted here. And we show that the controls are basically by these curved lines. Also within the room, we have three different receptacles, but no curved lines to them, so no switches. And hopefully this chapter, I mean, like I say, we start getting into looking at prints and we start getting used to seeing like what electrical symbols we are. And the good thing is they're very basic. We don't have a whole lot of different ones. Notice that a switch is a switch, a receptacle is a receptacle. What they do highlight is like different styles. Like, you know, if we have more than one receptacle, it would indicate that. Like if we had a quad going into an outlet, or if there's two switches, three switches, or something like that. Hold on for 1 second. Make sure I got this going right. Yeah. But when we look at so when we look at electrical symbols, it's basically with different styles we have. We got a device where it's any type of unit within the system that can carry or control electricity, like a receptacle, a lumen, that type of thing. It would be a device that's supposed to end up doing work. We would plug into it and connect to it that some which way. An outlet is simply basically any point in your whole system that's supplying equipment to, I mean, supplying current to something. So an outlet could, like I say, it could have switches within it. It could have receptacles within it. But essentially the idea is it's going to have something coming out of it. Excuse me. And a receptacle. And these are just terms that we're, you know, just to get familiar with using these terms. Because a lot of people just call things, you know, oh, that's an outlet. And it's like, no, that's not an outlet. And it's like, it's a receptacle. And a receptacle is something where you do plug into it. And it's basically it's receiving, right? So if you're going to plug your vacuum cleaner in, you plug your hair dryer in, or some other device, your microwave or something like that, it's going to get plugged into a receptacle. Now, if we say different styles of outlets, like a receptacle outlet or a lighting outlet, so in this case, what is a lighting outlet? Well, that's supposed to have a direct connection to a lamp holder. And that'd be something you'd find up in the ceiling, right? So we would have our light fixture hooked up to the lighting outlet. And then along the floors and whatnot, we would have our receptacles going into receptacle outlets. And these are all outlets. So essentially you have a box with wires coming out of it, meant to be hooked up to something at some point in the building. And we get some odd ones in there. We can have split wired receptacles where they share the same box, but they don't share the same wiring. That'll actually be drawn out on the plans and it'll show it as such. And our job is just to recognize that, okay, these are not shared, because you can have 2, 3, 4 receptacles in a box and they can all share the same wiring, share the same branch. But in the case where sometimes you might have them intended for two different things, let's say you had two receptacles sitting within the box. Now one was meant to be used by just anything, where you like plug your vacuum cleaner or a light or something like that into it. But the other one was meant to receive, like, let's say a window air conditioner or something. So that receptacle would be different from the other one, and it would be indicated on the plans. And that's what they call a split wired receptacle, where they do not share the same type of wiring. And then you'll find there's a variety of symbols we use. The good thing is, in your Uglies book, you actually do have charts where it does have most of the standard electrical symbols that are used. And you'll see that the style, like, so here we have receptacle outlets. All of these ones on this page are basically intended to be receptacles of different types. But you'll notice the one thing they do all share, they are all similar in that they all have like the circle indication here. And then we see that we have like the lines drawn through it, and each type of line and the style of line will differentiate what type of receptacle that's meant to be. And there's a variety out there. So of course we have a variety of symbols that we have to go with, but you'd be able to look these all up on charts. And it's one of those things where unless you're doing it every day, you're not going to know these symbols just off the top, like, oh yeah, I know what that is. Maybe if I do this one every single day, I'll know what it is without even thinking about it. But some of these other specialty types, yeah, I'd have to look up on a chart and see what exactly it is. And based on that, then I know how I'm going to wire it up and how I'm going to hook everything up within the outlet. The same with switches. There's a variety of switches out there. Now we could have an outlet box that has several switches within it. Now when they talk about the switches and they talk about like single pole, double pole, a single pole is basically one switch. It has literally just the two wires to it, right? But they're meant to be one run line. That would be a single pole. It's just running one line. Now, if I'm running two lines with it, that's a double pole. And that's what they mean by pole. It's just like how many current carryings do you have going through this thing? And then like in a single pole case, well, I just have one line. It's just one thing being controlled. I only have a single pole. But if I have like a switch where I want to control two different lights or something like that to it, right? Let's say you have a long hallway and I have like a couple of different lights, but I all want to run on one switch. Well, that would be something where you would have like a double pole switch. Oh, there we go. And again, they have a variety of these types as well, depending on what it is. And they'll have it drawn out as such. And again, look up the symbol, see what it's involved. And that pretty much tells you how this thing is supposed to be connected or how it needs to be connected. Excuse me. But they'll have things drawn out depending on the circuitry involved, and we have to recognize the lines for that. You'll notice that we use the curved lines for the switching to indicate where that's being connected up to. They'll have lines like this drawn through where it's like, yes, you're supposed to be running conduit for this. And it'll even indicate, how the conduit's supposed to be run and connected through. And again, we would have to just look up the symbols on the plans. So really this is, a lot of this is just looking and getting familiar with looking at building prints. And the exercises I actually have for today, and there's 3 of them, where you have to go through 3 different things and look at your prints. There's drawing 6, which is an indicator, yeah, it's going to be on drawing 6, and then drawing 9. But then there's another one, it's chapter 2, structural features. And that one is things that are actually outside of the electrical world, where I'm actually, asking you things to look up on the plans, like dimensions, measurements. Even one, I ask you what the front porch siding is, because that's all indicated on the plan. And I want everybody to be able to recognize, because when you get a set of prints, it's for everybody. Every trade that's going to be involved in building this structure, they're all going to have their details on these prints, and you overlap. So it's like, get a good idea. It's like, okay, well, the carpenter's going to be doing this. The cement guys are going to do that. The HVAC guys are doing this, and I'm the electrician. I'm doing this, that kind of thing. But, and everything, yeah, everything's like a lot of laid out by symbols. They don't show actual connections. It's your job to figure out how you're connecting this thing up. But we use the symbols to indicate what type of thing it's going to be. And based on that, that tells you how this thing would need to be connected or how it needed to be controlled. And it's all by the use of symbols. That makes sense? Sounded like somebody was hesitant there. No. So, but that's really it. And then you just, like I said, you look up these symbols on charts. The NEC has every symbol out there. Cool thing is this day and age, you can actually even pull this stuff up on your smartphone. You know, it's like, just type in, it's like electrical symbols, and you would be amazed at how many different kinds of charts are out there. But your uglies book has the symbols in there, the more commonly used ones. Um, but that's what I just want you guys. I'm not gonna beat you to death with these prints. That's our primary thing there. And then a little later, I got an exercise where I'm gonna have you like size your service entrance. And again, it's gonna be based on the prints, because the prints basically tell you, it's like, oh, this house needs this kind of power. And so, and then we're gonna be doing an exercise like that in a couple of weeks. But so we'll be going back and forth with the prints a bit, just to, get you familiar with using them, what kind of details and information we can pull out of them, that kind of thing. But anyway, so here we go with the receptacle outlets. Very typical. Yeah, like I said, you cannot allow any, well, no less than 6 inches. And really, when you get down to it, how long that is, you could just literally just about measure. And I mean, it's not going to be exact. Everybody's hand's a different size, right? But if you were to grab the wire and one end and go to the end of your thumb, okay, like sticking out of the box, that's where you cut. That gives you about 6 inches coming out of the box, no more, no less. That way, you know, you don't have too little, you don't have too much. I mean, it's always okay to have too much. You can always cut it back, right? Too little is a nightmare. So you always want to make sure you have enough when you're pulling your wiring through, before you like cut everything or anything like that. Make sure you have sticking out of that box at least enough where you can grab a hold of it and put your thumb down to the end of it, and then you can cut. And that should be enough to be able to, hook something up to it, a switch or a receptacle. So in this case, we're looking at a receptacle, and the highlights are as such. So we have the three main lines we would ever really find within a receptacle box. We have a hot, we have a neutral, and we have a ground wire. Yeah, you never want less than 3 inches, and 3 inches is kind of a nightmare to be working with. You can do it. It's going to be tight. You're not going to have a whole lot of room to play with, as far as connecting up your device to this thing. It's always a good idea to have at least like 6 inches coming out of that box to work with. Like I say, you can always cut back, but yeah, you don't want any less than 3 inches, just simply because of the stress involved. Because if you don't have enough wire, you're going to be running tight, probably pulling real hard, and that's never a good thing. Because over time, if you have something real tight on a screw lockdown, it might come loose over time, just because of the stress involved. But that's very typical, pretty standard receptacle outlet, single gang. You can only get one guy in there. You see the top and bottom screw holes only meant to hold one device. And that could either be a switch or lighting. Lighting, generally, yep, we're usually up in the ceiling, not always. And depending on how it is. But again, the same rule of thumb applies, is how much wire you want coming out of it. In this case, though, now we're looking at how many wires we're going to be stuffing in the box, because usually you have runs going through when you have lighting. So in this case, we have the white coming in, connecting up to the light itself, and then continuing on. And the same with the black going through like that. So if you really think about it, we end up with not 2 wires at this point, because the other ones count as well. We actually double the amount of wiring we have in this box. So depending on how deep it is or how shallow is how much we're going to be able to put in there technically. Because otherwise what happens is you start getting too many wires in there, and you're trying to stuff this stuff in there. There's a lot of factors that go into this. And I mean, heat is a big one, because heat's always, expanding and contracting when it cools off. And that can loosen up connections over time. Also bites into insulation over time, if it's stressful enough or tight enough. So sizing up your electrical conductors within a box is pretty important stuff overall. But anyway, continue on. Chapter 2, yeah, like I said, it introduces a lot of concepts of plans. So looking at electrical symbols, anything that's considered an opening is a lighting outlet, receptacle outlet, could be a junction box or any other type of enclosure. And we'll talk a little bit about junction boxes here in a little bit, because they are different. And you don't want to confuse a junction box with a lighting outlet or receptacle outlet, because they're not the same thing. A new term for everybody. This is how they like to say it. So if you actually go through and order this stuff, you know, you go to your electrical supply or something like that, believe the catalog, they're all listed as luminaires. It's not a light, it's not a lighting fixture, it's a luminaire. So a luminaire is considered basically anything that's going to provide light. So if you have lamp or lamps, any kind of lighting source would be considered a luminaire, and that runs for everything: LEDs, you know, halogens, regular incandescent, fluorescent, all the different styles of lighting that we have out there. But basically, it's considered a luminaire. And that's your new term of the day, I guess, if you didn't catch on to that in the chapter already. But so, and then the other consideration that you would have is your outlet locations determined, right, by the amount and type of illumination required. And this will usually be spelled out within the plans. It'll tell you like what kind of light you may have up in the ceiling. The ones that get interesting is when we start getting into like recessed lights, where we have several recessed lights throughout the structure, that kind of thing, type of illumination required. So you have to determine, based on the symbols drawn on the plans, you know, where the location is, what kind of light it's going to be, you know, and the type that it's going to be going into this. But if we were to look up Article 314, it'll have a lot of detail about outlet boxes, you have pull boxes, junction boxes, conduit bodies, which can be like a raceway, you know, a metal run with like a lid across it, that kind of thing. Throughout all of it, though, everything has to be always securely mounted and fastened in place. You should not be able to move a box once it's installed. That would be a huge no-no. And there's several different ways to mount these boxes as well. Usually, like within like the construction style of it, you can usually get in before like the plaster guys get in and put up the walls. Makes mounting much easier. But even then, there's ways around it. They have fasteners that can actually attach to the plasterboard and hold the box in place with tabs, lockdown screws, and that kind of thing. You'd be amazed at how many different style they got. Oh my God, so many different ones that'll lock behind plaster and lock a box in place without actually being mounted to like a stud, you know, a 2x4. But anyway, but these are, yeah, Article 300 pretty much has all the wiring methods out there. So if we were to look up it blindly and just start looking at Article 300 and perusing through it, we would find that all the different styles of wiring methods would be laid out in there. How we're going to mount these things, what they consider to be securely fastened, that type of thing. This is not that case. This is not securely fastened at all. And basically over time, these things will come undone. Their fasteners will get loose and that type of thing, especially when exposed to outdoor conditions. You do not want to have this. But anyway, so if we were to look up, like, let's say Article 314, it has a lot of very specific details about what they consider the installation and the usage of electrical boxes. So there is a right and a wrong way to transition. A raceway, which would be like a sort of a rectangular run box that would end within a flush mounted box, if you will. And we can have traditionally the boxes were all metallic. These days they're getting more and more towards non-metallic, or like the PVC style, where basically these things are made of plastic. I'm old school. I don't like plastic very much, but I mean, it is what it is. And they do a lot of it these days. Okay, there are do's and don'ts to connecting to connecting to boxes. Things that are allowed or not allowed. So essentially, the problem with this, if you see the silhouetted attachments where they have these connections coming in behind this box, those are allowed. The one that's the problem is this one that's flush mounted on the outside and going in to the box here. And the problem with this is simply this. There's a cover on this. Let's say this is like a junction box or even an outlet box, but there's a cover plate that goes onto this thing. And now by you having a rigid pipe going onto that cover plate, there is literally no way that you are going to be allowed to remove that cover plate without some extreme thing here where you would literally have to redo the whole conduit at the same time and that kind of thing. So something like this, no, this is not allowed. And believe it or not, this actually comes in, the Article 314.22, where they would show you things like this. It's like the do's and the don'ts styles of mounting boxes and connecting to them. But yeah, you're not allowed to go through like the outside and go through the cover where you can't remove the cover. If you were going to do something like that, they have these extension rings they look just like the box with no back to it. And then there's like 2 slots where it can lock onto the screw mounts onto the box here. And it would allow you to come out, and it's got pre-punches on the sides, like 1/2 inch and 3/4. And this way you could bring your pipe in, lock into the extension ring like that, and still be allowed to put your receptacle or whichever, or your luminaire or whatever device you have connecting up to this, even a cover plate, without compromising it. Because if you have a cover plate of any kind, it has to be able to be taken off and put back on very easily and very readily. But they do talk about that, believe it or not. NEC is like amazing on how much stuff they cover. And then we get to this one. Now this is allowed because it's flexible. So when I need to take off like this cover in this case, I don't have a rigid pipe that I'm ending up fighting here. This flexible, it's like Flex Seal. It's bendable. So you'd be able to literally take the cover off of this thing and have the flex fall with you without you having to fight it or redo the entire thing or anything like that. So surprisingly, this one is allowed. It's not common. Typically, it's what you would consider like a bad practice, if you will. Anyway, but these days, especially out here, most of your stuff is done in non-metallic boxes. They're cheaper. They actually have a couple of doodads with them where it makes it easier in some cases. Some of these plastic boxes now have little like lock tabs where you don't even have to buy a separate connector. You can literally push your Romex through these lock tabs and it'll lock it down where you can't pull the wire back out of it, and you don't even have to buy a separate connector for it or anything. It's literally an all-in-one unit. So you save yourself some money and some time by getting the nylon boxes, plastic. And another new term for you guys is a term they call ganging. So when we have the boxes together, it's like how many devices can the box hold in it? And each device is considered a gang. So if I'm running where I could just, like in this case, the box in this picture is a 3-gang. I have 3 different screw mounts on here. So I could have 1, 2, 3 like receptacles or 3 switches all mounted on there. And so when you run into this term, they talk about, okay, you need to install a 3-gang box here. That's what they mean. They mean a box that's capable of handling 3 things. So if I had a 4-gang box, I would have to have it where it would have 4. 2-gang is 2. Single gang is of course the most common one. But that's what they mean when they're talking about this. When they talk about single gang, 2-gang, 3-gang, and 4-gang. And they're talking about how many things you can mount inside of that box. So, see, it's a fun day. Lots of new terms, right? Right. But again, in NEC Article 300, right? We're this case, we're looking at 314.20. And this is like a broad, kind of a broad rule. So if you have a non-combustible surface material, right? And when is a case that you have this? This is like insulation that'll be inside of the wall and the ceiling. You know, a lot of times your exterior walls, and especially your ceiling, you're going to have insulation in there. And this is what they mean by non-combustible surface material. So when you have something in there, you can't have this, because you got to figure you're going to have this thing, it's going to have a certain amount of heat to it. And if you have it all swamped in, especially with that loose fluff fill insulation, you can't have it like all gooped up and around where you're going to have your device and stuff like that. You do need to have it set back a bit, if that makes any sense. You have to allow a certain amount of space so it has clearance, if you will. Even to the point of how we mount our like nails or screws, of how long they will be. And in a case like that article that I had you guys go through, right? You know, the sizing of our screws and going into walls blindly, it becomes rather important because you have to actually consider where is everything meeting, how's everything joining. But we do look at different things like this, and then we have to set a certain amount of clearance. And this is even dealing with the normal walls that we deal with, especially if we deal with like concrete versus drywall. Concrete, if you were able to get involved in the preliminaries of it, you can mount a lot of your stuff before they pour the concrete. Generally, if it's afterwards, you're not going to be chiseling out concrete, so generally you're going to be mounted on the concrete. Whereas drywall, we're allowed to cut into drywall in certain cases and mount things, if you will. But again, NEC estate, yeah, how much clearance that you can have, or how flush is flush. Does everybody know what they mean by flush? Oh, the dead.
Yeah, I do.
You know what flush is? So if I say it's a 1/4 inch back, is that flush?
Yeah, you want your outlet flush with the wall. Or not your outlet, your receptacle to be flush with the wall. Correct?
So that means when I'm mounting this box, I probably don't have the wall up there, but the plasterboard is going to be a certain amount of thickness, okay?
Mm-hmm.
But you don't want your box to be mounted so far forward that when the plaster guys come through and put the plasterboard up, you have any lip sticking out, because then it's like, oh, damn it, now you got to redo the whole thing, and it's becoming a small nightmare because now you have a finished wall to deal with. So yeah, you have so far that you can be set back. It can't be set back too much. It's inaccessible. Set too far forward, it doesn't become flush. And that means even with the wall, with the finished wall. Sorry. And these are very common these days for your plastic mounts. They already have the 2 nailers already in there. So you basically grab these when you have a whole box of them and you're going through and just mounting these things through, you know, an unfinished wall. This way you can go right up to your wooden stud, measure out how much you have to be up, and then start pounding away. Now, typically when they measure these things through, we do a thing that they call on center. Anybody know what on center means?
Center on center. Well,
On center.
it depends how you're measuring it. If it's on center on studs, it's the middle of the stud, from middle of stud to middle of stud, 16 inches.
All right,
On
what
a
about
box,
the on center of the box?
it'd be the middle of the box from the bottom screw hole to the top screw hole.
Okay. And you'll find that term used a lot. So when they say on center, yep, they're talking about literally the middle of the box. So if this box is 6 inches long here, the center would be 3 inches in. So if I measure up, let's say in my drawing, right, it goes 46 inches and it says OC. So 46 inches on center. So I would literally go up with my tape measure, 46 inches, set the middle of the box to that point, and that's where I nail it down. So again, another little term that you would run into, but that's what they mean by on center. And so this guy, he's even making sure he has a piece of plasterboard here make sure that it's flush. So that way it's not going to stick out past the finished wall, and it's not going to be set so far back that it's impossible to work with. And that's a good, believe it or not, a lot of these plastic boxes now come with a little line drawn on it where you can line it literally up with the stud and be perfect. It's got like a measured thickness of how thick the plasterboard is. And yeah, you can just go ahead, you measure on center where you're supposed to be, and then just line up that little line and drive her home, and you're good to go.
And on the inside of them, on the inside square now, they have like a little ribbed nipple type thing that shows where center is of the box.
Oh yeah, that's right. Yeah, see, and you didn't get that with the metal boxes because they're able to do all this stuff with these plastic boxes that they couldn't do before because they just build it right in. Yeah, yeah, it's kind of, it takes all the fun out. It makes it a lot easier. It really does. That way you can literally just go up and eyeball this stuff, and 1, 2, 3, you're good to go. Measure out real quick and then just push it in and go. Because before you had to do, a certain amount of measuring, make sure your box is, where it's supposed to be and all that. But yeah, now they all come with preset lines and stuff. Anyway. So, yep, always your main number one thing, right? Always, always, always look at it in a way, how is my wiring being brought to this? You want to do it in a way where it's not going to get damaged. Sometimes you have to be creative, but you have to be protective. Like if you did go through that article, you'll see that the electrician kind of cheated. And they do have these, and they actually have a few different styles of those protection things. And it's like a little steel plate, but they also make ones where they're even like half circled. So let's say you're drilling through a stud, right? Putting circles through the stud to run your wiring through. They make little half circle nailers too that you could slide right into that circle of the stud and protect your wiring as well. But a lot of people don't realize they have these things out there. But yeah, you can buy the whole stack of these little nailers, and they're actually a pretty cheap price. Little precaution thing for beforehand. It's always good to have it. But because once you're in and once your wiring's all locked down, you have the finished wall, nobody can see where this stuff is. And homeowners over time, you don't know what they're going to do, even mounting a picture in a wall or something like that. You do not want somebody to nail or screw into your wiring. Now, if you're running your whole home with like conduit, where you have EMT through the whole thing, well, you're pretty good to go. But most houses out and about here, no, they're all done with Romex, the non-sheath metallic. So you have to think how I'm going to protect this stuff when I'm running this wiring through. And so when you're doing your box mounting, you got to kind of consider, it's like, okay, how's my wiring going to be installed through this? Because there is no definite like set thing of plans of how your wiring is going to be run. That's the creativity part that usually you're allowed to come up with as the electrician installing. A lot of times you have the windows in the way and this and that, so you have to be creative on how you're running your wiring through, where you're connecting up. And so that's always a mental image you have to have when you're mounting your boxes. It's like, well, even though the architect said, well, I want it here, maybe feasibly, it's not something that can be done. If I have to move this over so many inches to make it a better installation, that might be something that has to go through. So always, never, ever, 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 ever take the architect as like the Bible. It can always be changed. I had a case, we were doing a really pretty remodel in near north in Chicago, and they wanted these recessed can lights in this crown molding, right? But when we were going through the actual structure of this place, it had the corner bit of an I-beam was right where he wanted this can light. We're talking structural steel. And so my boss goes over, he's talking to the architect, and believe it or not, even though pointing this out to the architect, The architect was still arguing with them that we have to have that can light put in there. And it's like, there's no way. I mean, we would have had to get out like a plasma cutter and start cutting away a structural I-beam to be able to put this can light in there. You know, when it comes down to it, the architect is just, he's making plans, okay? And when you're running into the reality of it, not always does his plan fit reality. So sometimes you have to change things on the fly just for safety's sake or feasibility just from working. So never, ever, ever take the architect as the final, you know, the final say so, because he's not. Those plans can be changed if something's not quite right. And always question that.
Or engineers. Engineers are good for that too.
Oh, yeah, you know, because then again, it's like, I don't want to say it like this, but it's the paper pushers, right? So they're sitting at their desk and going, oh, yeah, this would be great. And they come up with all these ideas and plans. But when you get down to reality of the situation, it's like, yeah, that's a great idea, but, you know what I mean? You always got to have that mentality. But because when you're doing this work, sometimes you're going to run into stuff and it's like, there might be something already there. It's like, well, this pipe is already here. Oh, I don't care. Get it in there. It's like, okay, yeah, okay. I'm going to move this whole pipe just so I could get this box in here to please you. But you you have to take that with a grain of salt. So, and it, yeah, especially you do remodels. Oh my God, that's you. That's a lot of times when you'll have a lot of fun, because then you're dealing with pre-existing, you know, things that are already in place that the architect didn't know about. And what's our bottom line? Well, our bottom line, as always, is to prevent fire. I mean, that's when you really look at the NEC, that's their main goal, right? Is to prevent fire, prevent shock, and to protect people. So our number one is always preventing fires. So we got to look at it and think, well, if I do this, do I have the possibility of making a fire? And so you really got to think about that. And as long as you can go through your work and get to the end of it and go, no, I'm pretty sure that there's no way I'm going to get a fire in here at all, blah, 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 just by doing what I did. But always look at what you're doing, you know, and take it with a grain of salt. All right, fire prevention. So when you're running boxes, you are not allowed from wall to wall. See, these are two different rooms sharing a wall, okay? And you want to box in one room and you want to box in the other room. At no point are you allowed to share this space, because if I have a fire in this box in this room, and this box is over on this side really close like that, that fire could
Fire
spread,
another one.
right, and go right into the other room. Now see how this is like mounted way over here, far away from that box going into the other room? This is what you want. See how it says it should be at least 24 inches apart. So again, if the architect has gone through and he's decided to make this look pretty, but he's got it in a style that it's like this, you know, this is where, I'm sorry, but you get the call, because, and you can even quote code to them and be like, well, no, this doesn't meet code. You're gonna have to be this far apart. You know what I mean? But always remember that. Yeah, fire prevention. So in this case, one box would be mounted over here, and then 24 inches down, that's where the other box would be mounted. And yeah, that's to keep fires from spreading like from one room to the other really fast. But and the things we have to watch out for too, yeah, special insulation that they might have around cables or pipes, because a lot of times we might be running with a cable or a pipe just because it provides an easy way for us to get our wiring in and stuff like that. But we have to be careful with that special insulation to make sure that we have no way of causing a fire again. So if we do that, we have to make sure that we have no gaps or open space, you know, more than an eighth of an inch, which is pretty small, right? But, and these are all, like I say, chapter 2, like it goes through, introduces you to the building plans, and then gets used to start thinking of like the concepts and the layouts of these types of things. I'm not going to say everybody's going to be an expert at the end of this, but it's always something to think about. Um, you want the toughest, yeah, you want the toughest electrician job in the world right here, right? So some local electrical ordinances require a metal raceway rather than cable wiring, and that is all the city of Chicago. You will find Romex nowhere. It's not allowed. Everything in Chicago has to be run in what they consider a metal raceway. And usually a metal raceway is EMT, conduit. But sometimes it can be a rectangular box, but as long as that's like a metal enclosed type of thing. See, as you got a metal raceway installed in a resident, quite common to use 4-inch square boxes trimmed with suitable plastic covers. But again, it's got to be a metal box going to the metal conduit and that type of thing. Yeah, Chicago is really tough. Well, they probably have some of the strongest codes in the whole country. Here we get a couple of pictures for you. The way to mount things. There's one with the extension ring on it. Basically how to be flush and how not to be flush. As long as we understand what flush is, why we're mounting things with a certain amount of lip to them, or having them recessed, if you will, but basically always consider, the final finished product, what you're going to be dealing with. They also bring out something in the plans where you might have special purpose outlets. And that could be different things. You might have a 240 volt outlet coming through for air conditioner or space heater or some other high powered device that they might have running throughout the house. And that'll be a special, what they consider a special purpose outlet. Because then you would have 2 hots. And normally through most of your house, you'll just typically have a single hot and a neutral line. But in this case, you're going to be running 2 hots to this special purpose outlet. For whatever reason it is. And it could be even something like if you have baseboard heaters installed in a house or something like that, you'd have a special purpose outlets for each one of those. It all depends on what's going into the house. But we do it. And then if we look at, like I was saying earlier about how many conductors you're allowed in a box, there's several places you can look this up. Your Ugly's book on pages 105 and 106 actually deal with it. It tells you how many conductors you can get into a conduit, through your circular pipe styles, how many you can get into a box based on how big the box is, because all boxes are different sizes, different depths, and how many wires. So if you prehand, you know how many wirings you're going to have going to, let's say, a junction box or something like that. You can go through and say, well, I'm going to have X amount of wires going into here and be able to size it accordingly. And if you find, okay, this box is not going to be suitable for that, then you would have to consider putting an extension ring on it or something like that to give yourself more space. Because they're very adamant, if you were to have an inspector come through and he were to pop the lid on, let's say, a junction box, and you got this thing so crammed with wires, he'll make you redo it. And there's nothing worse in the entire world than having to go through a finished run and having to redo it, because you're talking about repulling wiring, remounting boxes, and basically redoing the whole work, and that could take quite a while. But things that will take up room inside of your box. You could have internal cable clamps, the connectors and whatnot, have fittings that go inside of the box. You could have support fittings coming into your box. Let's say you had to support the box for a chandelier or something up in the ceiling. So now you've got mounts inside of the box to support this thing. So that takes up room. And that's what, and they consider devices on a yoke. A yoke is a structural support to hold the box of weight. The heavier you have a lighting fixture, the more yoke you're going to need, to the point where you could have quite a sizable yoke meant to support a couple 100 pounds, or you could have a very simple little type, that would support just a couple of pounds. It all depends on your lighting fixtures. And then you have your equipment grounding conductors going through, taking up space inside your box. You might have
The thing you really do not ain't nothing but a thing.
But all these are factors when considering, how am I sizing my box? It's like, one size does not fit all. You have to properly think about how many, and like I say, 6 inches, up to 6 inches is considered one wire. Anything over 6 inches is considered two wires. So you'd have to consider that when running your box. And it's like, oh, this is not going to work. And all the different things that'll take up space within your box. Excuse me. But these are all highlights on getting used to boxing sizes. There's examples in the book, on how big, how large it is, how to size the box, how much square, how many square inches or cubic inches you have within your box available to be taken up. So an exercise like this, like how many number 14 conductors could be fit within this 22.8 cubic inch box. And I actually have specific examples for that. And the fun part is when you mix and match, if you have like number 12 wiring and number 14 mixed in together going into the box, of course, now they're different sizes. And so how much volume is this going to take? And in this case, you can even do, they got the formulas available, the tables that are, this also all comes out of the textbook, actually. When we do quotes like this and stuff, yeah, we're quoting specific code and whatnot. You can look this stuff up in the textbook. I don't want everybody, I mean, you can if you want, if you really feel you want to get a copy of the NEC, I'm going to warn you, the thing changes every 3 years. So usually most shops that you work at and stuff should have a copy of the NEC available for you to go through. But all these come out of the NEC. There's tables and charts available that'll tell you, it's like, well, if I have this size box, how many conductors can I go and put into that? And then you can deal with it. Like say, if it says you can, in this case, right, you can have 11 number 14 wires going into your box if it's this size, just to give you a rough idea. So, if you're running 12 wires in there, this box is not going to be the box for you. So they all come square, and really it's like how much depth you have and then the overall size of this thing. You got to take into consideration your plaster ring on there. You got plaster extension rings on there to give you more space as well. So like in this case, because you do have a mount that will push out, and the more extension allowed on your ring, the more space you end up coming out with overall in your box. So if you know that this is the only box you have that's available, but you need a little more space, you can cheat and actually get an extension ring that has more depth to it to give you more space. Otherwise, you're dealing with extension rings overall, and that'll give you more space. So there's different ways to get around, like if your box is limited in size. So very typical installation, right? Where you would have things spliced together like this. So when we consider this, in this example, there are 4 wires involved in this thing. If you look at it and say there's 2 wires, you're correct, but you're also wrong. For sizing, this would be considered 2 wires, and this would be considered 2 wires. So you would have 4 wires to consider altogether for this type of thing. And anything over number 18 size has to be counted. Anything under that, I mean, unless you have like a gazillion of them going in there, can pretty well be ignored. If you have like some real low voltage sensors, lightings are going in or something like that, you could pretty much ignore the sizing of the wires because it's so micro thin, it's not going to impact you. But a lot of times if we're like lighting, if we're using luminaires, you might have a very shallow box to deal with, especially something like this where you have an exterior mount. If the box size is very, very small, so you'd have to consider what size it is and how many conductors you can actually get away with putting in there. Yeah, and in this case, you cannot consider the actual fixture as being space. You have to literally think of it like just the sizing of your box alone. Sorry, I know this is a boring chapter. I'm sorry. So, like I was saying at one point, the NEC does not specify heights or locations. Believe it or not, the Handicapped Association specifies heights, where they say the minimum height of a electrical receptacle has to be this, where switches are mounted at this. Believe it or not, the Handicapped Association sets the heights on those. The NEC does not specify mounting heights or locations for devices. The only one that stepped in was the Handicapped Association to give a minimum, how far handicapped people can reach and how far down they can reach. So it's actually strange on how many people get their hands involved when it comes down to like electrical wiring. But we do have typicals, and there are, and like in special considerations, like in basements or anywhere where you're going to have like water or something like that. If we're considering floods, flood prevention, that kind of thing, we do have minimum height set for that. But as far as anything else, you could literally have all your receptacles mounted right next to the floor, technically. But usually they'll have the height specified in your plans. If they're a good set of plans, they'll tell you where they're specified. Otherwise, you do fallbacks. And we do have like typical heights shown for like, where a wall switch would go or what side high up it would be and that kind of thing. So for the sake of everything, let's just say that typical switch should be 46 inches. Typical receptacle is like 1 foot, right? So from a finished floor to the center should be 12 inches. Now remember that too. You always got to take into account that when they're talking about finished floor. So if you're in a case where you're in a house and the floor is not finished yet, and you got tile or carpeting or something like that, that's going to affect how high it is. So if you set it to the unfinished floor and you went, oh no, that's 12 inches. Well, that carpeting came in and now you're like, what, 10.5 inches or something like that. So you always got to remember what kind of flooring. And this is where you would have to look at something outside of electrical detail on plans, where you would have to look and see what kind of flooring is going into that room and base your measurements on that. It's like, oh, well, the flooring's going to raise this up by 3/8 of an inch, 1.5 inches, this and that. So that way you know where your on center is supposed to be, because it can vary from room to room. And we have special heights for like counters, kitchen cabinets, what they should be in garages. Garages, you don't want them too far low. Again, dealing with a case of floods. Unfinished basements should be relatively high up, almost 4 feet. Now, if it's a finished basement, that means, you have where it's all set for dwelling, where you're going to be actually be using a room like a family room or something like that. Then you do it like you do the rest of the house, where it's 12 inches on center. Anywhere outdoors, you typically want to keep it up higher just because of water. So outdoors, we would typically go at a minimum of about 18 inches on center or higher, depending on your situation. Now, sometimes you will have what they call wall luminaire outlets. So that's like if you walk into a room and you want to be able to, let's say you have a lamp plugged into a receptacle and you want to be able to turn it on with like a switch or something like that, that would be considered a wall luminaire outlet. And it could be outside or inside, right? Excuse me. But yeah, as far as positioning, there are no rules. I mean, you could technically put these things on a diagonal if you were feeling artistic, I guess. But there's only special rules as far as like fire prevention, which is like the back-to-back of boxes, that type of thing. But as far as positioning, believe it or not, there are no rules. In the finished product, now you typically want this. Now you'll notice like the older styles, ground plug was always down. But in the new styles, ground plug is up. And why is that? Well, they found that in homes, people hang pictures. I don't know why they do this. No. But if you have like a picture, let's say it's got a metal frame to it and it falls down and you've got something plugged into your receptacle here and that metal frame comes down, you got a hot and a neutral right there with that metal frame. What do you think might happen?
Oh, okay.
You know what I'm saying?
Yeah, I see what you're saying.
But if you do it with ground plug up, if that metal frame falls on your ground plug, who cares? You know what I mean? It's not going to damage anything, so it's protected. So yeah, and then they do that when if you're mounting side to side. You'll notice on these on the receptacle device itself. See, I don't know if you could see this, but see how there's like brass screws and silver screws and then a green screw, right? Well, the brass ones are the hot side. That's where you put your hot wire. The silver ones are your neutral, and the green, of course, is your ground. But when they recommend if you're doing a side to side, keep the hot. Basically, you always want to think of it hot side down, right? So line down in this case, so that way the neutral's facing up. So if something were to hit it, it's going to hit the neutral side and not the hot side. So again, you know, fire protection, fire prevention, if you will. But yeah, if you have the old style, a lot of homes do. Yep, hot sides are always up. But yeah, new style ground plug up, which always looks weird, it's even to this day to me. But that is what they found. Just a strange little thing. And I have a thing for you guys. That's the end of these slides, by the way. But on the homework question, and it's always never fails. My biggest one: what the heck is a junction box? What the heck is that? And why do I not want one in my first floor? So a junction box is a box that's designed to have a bunch of wires coming into it at a junction, right? So I could have branch circuits going out, you know, it might feed different receptacles, but the thing of it, a junction box is it can't be a totally locked away box. It has to have a cover on it that I have to be able to get access to. Now, if you look around your house, look around your apartment, you won't see any junction boxes because basically it would just be a lid. Where are your junction boxes at? Your
In the
junction
ceiling.
box. Yep, in the ceiling or in the crawl
basement.
space underneath, right? They are never, ever, 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 ever on the first floor. Ever. Ever. I don't know if I said that enough times. No, but you don't have these things. They're ugly. Nobody wants to see them. You don't want access to them, just everybody being able to go in and mess with the junction boxes, right? So yeah, usually up in the attic or crawl space and, you know, spider web out where it's a branch circuit, it feeds all the receptacles or it feeds the lights, right? But these junction boxes are hidden away. You never see them. You never see them. Might be down in the basement if you have an unfinished basement or a drop ceiling or something like that, or under a crawl space, that kind of thing. But yeah, usually they're up. They're up above. They're up above your head. You don't see them. Not ever. I just thought I'd highlight that. A lot of people have a hard time with that one for some reason. But yeah, if you look through the book, it does tell you. But yeah, junction boxes, never. You run a junction box, you're going to hide it somewhere. I don't know where, but it's going to be hidden away from the general living quarters. The only kind of boxes you ever see out in the living quarters are outlets. Outlets, and outlets, right? And outlets are for switches, they're for luminaires, and they're for receptacles. And that's the type of boxes you will see in your living quarters. Now, there's always the other boxes, like I say, the junction boxes, raceways, and that kind of thing. Those are always hidden away. You don't ever see those. But that's my lecture for today for you guys. I do have, officially, we assign chapter 3 homework today. And we assign the three drawing exercises. One for drawing 6, one for drawing 9, and then one's called chapter 2 structural features. And the reason being, this is stuff that you normally don't do when you're doing electrical work, but it's stuff you do have to take into consideration when you do electrical work, because you always have crossovers with the other trades. So I need you to be able to go through and identify like some of the things, and I ask you some pointed questions on measurements, even like what some of the finishings are or what this material might be made out of. But everything on those questions for those 3 exercises are all somewhere in drawings 1 through 10.
It's not real hard either. I think I already did that one.
Yeah, I mean, it's not real bad. It's just some of the stuff you do have to kind of go through and measure a little bit. For the chapter 2 one. But yeah, otherwise it shouldn't be too bad of an exercise for you. But I just want get you guys into the prints and get at least a little familiar with them, because in a couple of weeks we're gonna have like a 3-page worksheet exercise where you're gonna size the circuits in the house for me, down from the service entrance all the way through like appliances and all that. So you're gonna tell me what size you're gonna need for your house. And that's gonna be based on your calculations on what's going into this house and how much power it's gonna draw, what kind of special things you might need for your AC and furnace, your laundry room, your kitchen and all that good stuff. But
I'm
we'll
glad I
start.
just remodeled.
Huh?
I said I'm glad I just remodeled. I already know.
But everybody has fun with that one. It's actually a pretty good exercise. I like to do it because, I mean, that's basically what every electrician would do, even if it's just a remodel, right? You get your set of prints. It's like, well, how do you figure out what your job bid's going to be? So you go through and figure out, size everything, and then you can do a materials list, right? And then based on your materials list and hopefully a little knowledge on how long it's going to take you, and then you kind of make a job bid on that. Not that I want you guys running around doing side jobs, that's on you, but remember, license, and more licensing. You want a state license to do work. Otherwise, if you're running around doing unlicensed work and you cause a fire, well, have fun with that.
And when you think you have enough license, talk to the state of Illinois. They'll make you get another one.
Probably.
Mm-hmm.
It's not an easy test either, and the fee's not cheap. But yeah, if you do end up getting licensed, stay up to date on it. It's not bad once you get used to doing it. Usually I consider time to start thinking about a state license if you're like journeyman level kind of thing. And then I don't know.
License just to say you're from Illinois.
Well, no. Every state you're supposed to be licensed to practice a trade. Believe it or not, every state. You want to practice a trade, you got to be licensed. Because trust me, there are plenty unlicensed people running around passing themselves off as construction workers. I won't say anything about that, but you get what you pay for. But yeah, that's what I got for you guys today. And then, like I said, chapter 3 homework assigned today, and then those three drawing exercises and questions, if you will. But otherwise, that's all I got. You guys have any questions? Are you doing okay?
There was one thing on the calendar. I think might have been a test. Said I had to have a password for.
It does say that. How about that? You can't take it yet, huh?
Dang it.
Yeah, it's a chapter 1 and 2, or chapter 1 and chapter 2 quiz. That gets posted on Wednesday. But yeah, it's a take-home quiz. It shouldn't be too bad.
All right.
Yeah, I got password on every one of my quizzes and tests.
Yeah, because I was sitting there doing my homework yesterday, and I clicked on it. It said password, and I was like, well, maybe I wasn't quite for sure. Ain't a big deal. I just, like I said, I try to work ahead.
Yeah, I seen that. Well, no, that one I'll assign that on Wednesday, and I'll give out the password and here and in the announcements for Blackboard. That way you have, and then you can just go in and take it when you want. It's a take-home quiz, by the way. No. And
Does the book come with a companion site, website? Do you have any information on that?
say that again.
Does the, I should turn my fan off. Does the book come with a companion website?
Not per se.
Okay, I'll take that as a no. You don't want to use it.
What I can show you, if you really want to be an eager beaver, this is getting ahead of my game, but hold on here. I'll show you something. Let me just get this on here real quick. So, oh, come on now. Must be a busy day for them. All right. Oh, good Lord. Let me get this up and share my screen. So, these are the guys that make the NEC, okay? Up on top, you can see they have like a my profile set up and stuff. You can join for free. All right. And believe it or not, they share a lot of, you're not allowed to download anything off of this site. But a lot of the stuff here you can pull up, because if we actually look through and, look at the NEC, they do, oh my God, they do so much, but they have a lot of information on their website, even how to go through and get prepped and things like that. But they get their hands in quite a lot of stuff. If we looked at all the codes and standards they do, here's what we're dealing with, right? And see how they call it? It's basically in NFPA terminology, anything in the 70s is electrical. So it starts at NFPA 70, which is the NEC. But it doesn't stop there. There's other stuff out there. There's like, oh my God, I'm trying to think. What the heck? Hold on here. Yeah. Can you guys see that okay?
Yep.
Okay. So as you see, it starts NFPA 1 and goes to 2, 3, and so on, right? Fire extinguishers and all this stuff. There's stuff for, everybody pretty much. But once we get up, we notice, okay, we start at 70. That's where our stuff starts for electrical. So National Electrical Code. They even have like, see, like if let's say I was just going to do residential, I might just want to do this NFPA 70, right? Which is 1 and 2 family houses. They got 170B for electrical equipment maintenance. The NFPA 70E, which a lot of you might probably run into out there, which is electrical safety in the workplace standard. So you might be required to take and sign a little test, if you will. But they even have NFPA 72 is for the fire alarm stuff. They even have 73s for electrical inspectors and all this stuff. But you can sign up on this site for free, and you would be surprised at how much information it will let you get.
Thank you.
So if I want to look at the NFPA 70 National Electric Code, see that right there, but it's not downloadable. So you pretty much have to pull it down every time to look at this. But it does let you look through, and you can get some information on it. and that kind of thing. NFPA does like to share. But if you were to actually buy this thing, $95 electronic or hard copy. And there's another website that I like a lot. It all depends on how detailed you get into this. Let me share this with you. Oh, get out of here. All right. This is electrical construction and maintenance. All right. That's all these guys do. They have code quiz of the week, which with prizes actually. So they'll give you a picture and ask you, what's wrong with this picture? And you can send in your answer and see if you win and stuff. They have like how-to articles and things. They even have simple and with really good illustrations too. They even have like simple like how to wire I don't know. Let's look up some people here. Say three-way. You gotta remember, take this with a grain of salt. But I don't know what I'm gonna get here. I didn't look at it beforehand, but we'll see what they pull up. But EC&M, electrical construction and maintenance, they'll have a lot of information, all these quotes from the NEC. They give you really good tutorials and stuff, talk through things, what considerations you might have to consider when dealing with, mounting this particular device, if you will, all special considerations. But a lot of people don't know this website exists, but like I say, it's electrical construction and maintenance. So pretty much, if you're going to be doing electrical work, I would make a profile on this website and stay up to date with them. If you like to, stay up to date with current technology and that kind of thing. They also publish out a electrical magazine that you can get. I'm pretty sure that's free of charge for the electronics version of it. But you get that electrical construction maintenance magazine where it's, done out monthly and has different information that they run into on construction sites and even on maintenance sites and whatnot. But those are two websites I usually share before we get to the end of class. But since you're asking questions, yeah, I would sign up for both of those if it was me. But having these guys, NFPA, and it's free to make a profile. It's free to stay up to date with them. They have newsletters they publish out as well if you want to stay up to date that way. But yeah, you can go ahead and look at them. Oh, I guess the price has gone up. Yeah, it's $108 for the new 2020 NEC. In the handbook, there's $200. Stuff isn't cheap. But they do, yeah, even reference cards. You can have a free trial. But usually when you get into this kind of thing, this is something that your shop, where you end up working at, the shop should have like a library. And then when the library, if they're a decent shop, they should have a copy of this bad boy. If they're not a decent shop, well, this will be a good way to tell because they won't have a copy of this available to you. So if you're doing electrical work and you have a shop and they have a library, this should be in it. And if they don't have it in it, well, what does that tell you? I'm just saying.
Unless you work for the right company and they have a library, you just can't get to it because it's their corporate office and they don't allow you to work there.
Well, see, now that's ridiculous, okay? Because basically you should always have, like, let's say, I don't know, let's say you're in maintenance, all right? Let's say, you got a shop location, okay? Now, within that building that you work at, you have specific machines and stuff that are not going to be over in building A over here, if you're going to building B, right? So in your library, you should have like all the stuff for that place. And that includes a copy of this. There should probably, depending on what kind of work you're doing, but they should have stuff on all the bearings used and all that. And you should have a full library. And this is an indicator of whether you're working for a good shop or not. So if they're going for the streamlined, pretty look, and they didn't even offer you like an online version of this stuff, well, I hate to say it, but your shop sucks.
Pretty much.
And I mean, and I'm not trying to be a bad guy, but I mean, if they can't provide the materials needed, and this is a tool, right? This is a main tool for a technician, and this is an indicator on what your manager thinks you're going to be able to do. So if they don't have a library available to you, your manager thinks you're able to do nothing, right?
They have what they call a maintenance forum,
a maintenance
where you can go online and look up all the manuals supposedly for all the equipment we use. It's quite ridiculous because half the shit you can't even find.
Well, I mean, the good thing, certain stuff, I mean, like, I don't know, it all depends on what kind of equipment we're talking here. But if you're doing good, like PLCs and stuff like that, like Allen Bradley, the good thing is a good company like Allen Bradley does have all their stuff online.
Yeah, they offer it online.
I've done that where I've been able to pull manuals right up on my smartphone while I'm, like trouble codes and stuff. And I can look up Allen Bradley products. But again, your shop should have a library available. And that's just a given. That's almost like a no-brainer. I mean, I'm sorry, but
That's Caterpillar for you, though. Plus, they have so many contractors that run through there. They probably did have the manuals, and it just don't get passed on from one to the next.
Well, I don't know how you're expected to do the work if you don't have manual and drawings to do the work.
Well, they lost 700 pounds of refrigerant this weekend because they shut the water off and didn't shut the chillers off.
Oh my God. Is EPA getting involved in that little investigation? I bet, huh?
Oh yeah, they're there.
I bet they are.
They called me and I told them, I said, no. I left there at 6 o'clock. This is 9 o'clock at night. I ain't coming back in.
I worked at
Not my problem.
I worked at a place and they had liquid ammonia running through for their freezers, and the guy didn't know what he was doing and hit the dump valve.
Oh.
And it basically, he flooded this farmer's field next door with about 2 acres of ammonia gas, and it killed the crops, of course. And he's lucky that he did it like late at night because he didn't kill no people, but that would have killed people too.
That stuff's vicious, boy. Just a little sniff of it will make your eyes water and your nose run, you lose your breath, and that's bad shit.
Oh yeah. But yeah, they had and the fire department wasn't trained on the cleanup, so they had to basically go through and train some dedicated personnel as well as training the fire department crew on how to deal with ammonia. Anyway.
Yeah, it was funny. This Monday or Sunday morning when I went in, they had Caterpillar's fire department in white suits out there with respirators on. And I'm like, that respirator isn't going to do you no good. It's like it's refrigerant, for Christ's sakes. Yeah. I was laughing.
No, that's how they do it these days. Yeah, see, that's why I don't like the cookie cutter places, right? They're just, you start contracting out, you lose a lot of resource.
Yep. That's why my day was so slow yesterday. I just sat there on my computer doing homework, watching a chiller charge all day long.
Gotcha. Yeah, fun stuff.
Yeah, my boss was like, so you don't have to do nothing? I was like, yeah, I got to sit here and watch these gauges. That's what I did for 12 hours.
So funny. Ugh, God. Which building you work at out? You're working, wait, you're in Mossville, you said? The
Yeah, I'm out at the tech center,
Okay.
building L. It's where they do all their engine testing.
Yeah, yeah.
They won't get in no trouble over it, though, because half the engines they got in there right now are Department of Defense. So whatever happens will just get brushed under the rug, I'm sure.
Probably. Yeah, you start getting the feds involved, and it's like, oh. No, they'll probably still get a slap on the wrist, though, I'm sure.
Yeah, they'll get a $150,000 fine, but if you worked at Caterpillar before, you know they throw away $150,000 about 5 times a day on the
Yeah.
world's dumbest stuff.
They don't rebuild motors. They just replace them with brand new ones. Yep, I know.
Yep.
Just nuts. All it's wrong is a bearing. I don't care. Replace the whole thing. It's like, oh my God. All right.
Yeah. Yep. Let's take this 75 horsepower motor out of here and put a new one in. Scrap the old one.
Right. And that's what they do, which
Yep.
is crazy. Especially when it's something silly like just a bearing. It's like, oh my God. Because, I mean, typically those motors last for years and years, but no.
Well, out there, they run their engines until they blow. That's what they do. They have a engine out there that's, I don't know, it's probably 20 foot long by 15 foot wide. That's for like a cruise ship, and they have to blow that motor up within 600 run hours.
Wow.
They're running seawater through it or salt water through it instead of DEF fluid. Oh, it's just ridiculous. And they're just wanting it to blow up, see how much crap it can take.
Wow. That's how we're doing. That's how we come to consumer. Got to make it consumerable. You can't make a forever motor, otherwise there's no money in it.
No, they don't want to make a real good motor. They want to make a good motor, but not a really good motor.
Right. That's with everything too. Oh, I know.
They have a little shop out there. It's a conveyor belt that they have dirt they put on from different parts of the world, and they have these little itty bitty toy like bulldozers and backhoes that they have run on there, so they can get some engineer can get an idea of how long the buckets are going to last, where it's going to wear at. Someone probably gets paid $200,000 just sit there and watch that belt run all day long, playing with toys. It's literally a die-cast toy. It's retarded.
That's pretty funny.
Yeah. Alrighty. Well, I will see you on Wednesday, Tom.
Yep, I'll be here. You guys have a good one.
You too.
Alrighty.